Thanks everybody for coming. So today's session we're going to talk about scalable smart caching for Spring developers. It's a live coding session. My name is Pulkit Chandra. I'm the product manager for Pivotal Cloud Cache.
Hello everyone, my name is Nikhil Chandrappa. I work as a platform architect at Pivotal. I specialize in data services that are coming out of the platform.
Okay. A couple of years ago, Netflix had this conference, Strange Loop, where they actually talked about their caching solution. They talked about how it's a really important part of their architecture and how they, by introducing cache between their data stores, they're able to make their whole system much more efficient. For obvious reasons, backing data stores, like typical data stores like databases, are not exactly tuned or designed to handle a lot of traffic that is coming in. And hence, introducing a caching layer in the middle, it's just an efficient way of handling that kind of load because caches can filter down to the databases that how many requests they really have to make. So it's just efficiency. It's a pretty standard technique in computer science to just memorize what you're doing. Now, if you see what they have, what are the different areas at the scale of Netflix, it's touching caching. They're signing up service, logging service, searching, viewing title details, and everything basically that you do, you're browsing your titles, all these things are coming out of their caching solution. Now, this is pretty amazing if you look at the scale at which Netflix operates. And the most interesting thing when you actually look at how did they do this is that they have hundreds of terabytes of data in this cache. And there are trillions of hops per day, and there are tens of billions of items stored, and millions of ops, and thousands of servers, hundreds of microservices, 3 regions, and 4 engineers that is managing this. Now that's the key thing. You have got 4 engineers managing an infrastructure of cache that is handling terabytes of data. Now, how do we do that? One of the key things there is automation. You have to create an infrastructure and a caching solution from ground up to do this. They did it, but not every company needs to create an EV cache. So this is the kind of motivation that made us think about how to do this at scale for enterprises. And Pivotal Cloud Cache was our answer. So it's a distributed in-memory cache, which is optimized for PCF applications. So we do a lot of integration, a lot of work to make sure that it works well with the PAS or PCF workflow. It does automated provisioning and management, thanks to Bosch. So until the infrastructure is required by a developer, so let's suppose a developer wants to spin up a cluster, and she's going to go ahead and create a service, and that's going to spin up a full cluster. And it's highly available because it's not a single VM that gets spun up. So it's a clustered service, and you can actually scale that service without impacting any of your application which is interacting with this cache. It's fault tolerant just because of the fact that it's always, there is a single process running on a single VM, and there are different VMs getting spun up. And hence, there is no single point of failure. When a single VM goes down, it's not like multiple processes are going down. It's just one process that will be going down. And it does support disk-based persistence. For some reason, if you want more reliability, there could be DR scenarios that you want to imagine for your cache, because loading the cache could be a really heavy thing. So you can actually enable a disk persistence feature, which synchronously writes to the disk while the writes are happening to ensure that the data is not lost if for some reason the whole cluster goes down. This disk persistence is managed by Bosch, so it's even if the VM goes down, it kind of reattaches it, and as soon as it bounces the VM back, it reloads the cache. You can actually WAN replicate it. That means you can have multiple PCF foundations talking to each other using this PCC cache. And it's PCF AZ aware. So because PCC internally shards the data, It maps individual shards to availability zones, and it has copies. There is a primary copy and there's a secondary copy. The primary and secondary will never be on the same AZ. So even if the whole AZ goes down, the chances of data loss is really low. There are multiple design patterns that we can support. I'm going to go over a really simple one, which is a Lookaside cache pattern. It's really simple. You have a Spring Boot application, which is talking to your cache and your data store at the same time. Now, this can be supported by, especially by Spring Boot annotations like @cacheable and things like that. And there is a first-class support with the new project called Spring Boot Data Geode project that is in M3 release right now. It's going to be released pretty soon, RC and GA. And this is a pattern that you can easily implement with that. For more extreme applications, there are inline caching patterns that we can support, where the logic of keeping the data synchronous between a cache and a data store relies on the cache itself. So the application code becomes much more simpler because the application code is not responsible for managing the state of two different places. Obviously, this is recommended for more heavy-duty applications. For most of our day-to-day typical applications, Lookaside cache pattern really works well. Here are some of the developer essentials when you think about programming with Pivotal Cloud Cache. So PCC topology, the way it looks like is that you have a PCC client. It has a small jar file as part of Spring Data Geode project, which is the open source core of PCC, which maintains a connection pool. Now, what that connection pool does is that it maintains a direct connection to all the cache servers in which actually hold the data. Now, the locator processes that you see there are nothing but management processes. They don't hold the data. They just manage the membership. And the fire that you see there is basically a server going down and how the shard which is on those servers would instantly it would have a secondary copies, and those secondary copies would become primary copies, and new secondaries will be created on the other servers as soon as a VM goes down. So this is how we maintain within the cluster a level of availability of the data, and the data doesn't get lost. Another key thing to keep in mind is that we have drawn AZs around these infrastructure, that we are AZ aware. As I said, if the whole availability zone goes down, it will never happen the primary and the secondary both go down together. The secondary copy of the data would always be on the second AZ. And ultimately, this is all managed by BOSH. That means every time a process goes down, BOSH is quickly going to work on it and trying to bring it back up. So even if the system goes, if there is a blip in the system, it's for a very small amount of time. All you have to do is just monitor. There is an out-of-the-box monitoring integration that you can do, and you can just see it blip, and that's the max impact that you will see. Now, there are two types of members in PCC. I was briefly touching on that. There are locators, and basically there is a cluster discovery, which locators do. So as part of the membership responsibilities, what locators do is that a client application connects to the locator, and that client application gets the membership view from the locator. Once it gets it, it can directly talk to the cache servers. It no longer needs the locator from that point on unless it has to reinitialize the pool. And it also does a load balancing of the servers in case the multiple clients can be connected. You can have hundreds and thousands of clients connecting to single cluster, and it will do the load balancing. Now, the cache servers are the real servers who are storing the data. They are the ones who are storing the data in memory. They are the ones who are storing the data on the disk if you have chosen to do that. Regions is a nomenclature that PCC uses to represent hash maps. That's what it's equivalent to. If you think in databases world, it's equivalent to a table. Now, it's a key value store. So you can basically insert any type of objects in it. It recognizes Java objects, and the way it shards it, it has a concept of a bucket. As any other hash map, it basically divides the whole map into a number of buckets and then shards the data between those buckets. We basically have, by default, chosen a nice prime number, which works really well, that we have tested against. It's 113 by default. There are two different types of regions, if you think about these maps. One is the replicated one, where all the copies are on all the servers. It's not sharded. This kind of region can give you a very nice read performance, and write performance. Every write, it's going to replicate to all the members, so obviously it's not going to be that great. But in most of the cases, partition region is something that we recommend, because if you think about replicated region, even if you scale, there is not a lot of memory that you're getting extra. At max, what you're getting is ability to handle more connections. In a partition regions, however, if you scale, you actually get overall more memory, because it's sharding the data between these different servers, and it's not just saving all the copies on a single server. So these are the two different kind of regions that PCC supports. Now, we support scaling out. It's pretty simple. It's simple as CF's update service. Just give a new number of servers that you want, and it'll just scale it out. You wouldn't even know what happened on the application side. It'll just balance the whole data. After it's done, you'll just see that now with from 10 to 20 servers, the data is balanced, and everything is just the way it's supposed to be. All right, Nikhil?
Sure. Thanks, Pulkit. So Pulkit gave a good overview of what PCC provides, right? Let me quickly blow this up before I get started. Okay, cool. Are you able to see the screen? Cool. So PCC by default uses, our PCC is built on top of Apache Geode, our pivotal Gemfire, right? In core, it uses all the same libraries. So there are like multiple ways that you can connect your Spring Boot applications to a PCC server. One can be like a native API, or we can use the Spring Data Project. So Spring Data Project provides really good capabilities working with PCC. It's like it brings in the auto reconfiguration so that you don't have to worry about how the connection information is getting retrieved by the Spring Boot app. It will pretty much, it knows how to parse the VCAP services for getting those information. Apart from that, all the things that you were familiar with Spring Data, like Spring repositories or Spring index support or transaction support, everything will be, everything you can use with Spring Data, Gemfire, and PCC. So in order for a developer to get started with PCC, right, what he would have is he would first go to Marketplace. Let me quickly show how Marketplace would look like. So in Marketplace, your operator will go ahead and install your PCC tile, and you will see something like this, where you'll have multiple plans. As Pulkit said, it's a sharded architecture we'll be using. So there are like different sizes that you can use or based on the capacity of the cluster. So an app developer first will go to his space and start creating a PCC cluster. He'll give an instance name, and if he clicks on create, PCC or Ops Manager will go ahead and provision the VMs on the fly and bootstrap the cluster. So none of the VMs come up until developer requires it. So it's kind of on-demand service capability that we bring with PCC service. So that's the first step. And then he should have, in order to implement connecting to PCC, there are like two libraries he would have to bring down. So in his Maven repository, the first library that we are using is Spring Gemfire Starter. This is like a boot it provides auto reconfiguration support with Spring Boot and data jump fire. So we are working towards the GA version of it. Right now, we are in milestone versions. Similarly, we are working on a test dependency for PCC as well. So that whenever you are you want to do unit testing, right? You should be able to mock some of the client cache objects that PCC requires. So, otherwise, most of the times we would end up doing integration testing where you would have to do a CF push. So that will probably reduce the developer productivity, right? If you're not able to test it, or you will not able to do your TTD and all those kind of things. That's why we are working towards a Spring Data Geo test library. And as the next step, what developer would do is, like, he will need to annotate his object models with annotation called @region. So what @region specifies is the name of the region where I have to go and store this customer object. So in this demo, what we are trying to do is, we are trying to do a Lookaside caching pattern, caching implementation of a customer search service. So in the customer search service, if you see here, I have a customer search service where I'm retrieving data using email address. Right now, what the simple use case can be, all your microservices are going against, let's say, Oracle or some DB2 databases, and as and when you move to more and more microservice hierarchical architecture, it will be like it reduces the increases the latency, or it increases the latency for your end users, right? Since you are always hitting your databases. So in order to avoid that, similar to how Netflix cached all their data, we can also cache some of the responses using Spring data annotations like @cacheable. So in this Lookaside caching pattern, I can implement that with using just one annotation called @cacheable. So and this is kind of a pluggable architecture. What I mean by that is, so today, say you have this code already written. If you just want to enable your app with PCC, only thing you would have to do is go ahead and create a cloud cache config file. So in cloud cache config file, you see there's like bunch of annotations that we have here. These are the main annotations that we will be using. One is called as enable durable client, which says for a Spring Boot application, this is a PCC client, and I want to make a connection to PCC cluster. So this is the only configuration change one has to do if he has to enable his Spring Boot application to work with PCC. There is no other code changes. That's it. So as I said, we'll also support repository support. Similar to JPA repository support, we have something called as Jumper repository. If you see my customer object, I'm annotating it with both. Since I'm using like a Lookaside caching pattern where I'll be working against the database as well as the cache, you can have the same annotation, like you can have on the same object annotations for JPA as well as PCC region. So, right now, what I have done is, let's just say we are starting in a place where we already have written code for connecting to database. I have to go ahead and add caching to it, right? Quickly, I'll say, okay, I'll go to my customer search service and say I'll add a cacheable annotation. This is where the Lookaside caching will get enabled. So, and I have written test cases also, right? For my application to do some unit testing for, like, let's just say I'm unit testing my customer search service. I have mocked it out. So this unit testing will, with @cacheable enabled, this unit testing will fail because I'm saying I am looking for so the first test that I'm doing here, which is like looking for the client cache. So if I don't have a server-side connection, or if I'm not running on PCF, Either you have to run a local version of PCC, or you can mock it out. Right now, if I run this test case, it should fail, right? Because I am not giving it any server-side connection to it. So let's just quickly go ahead and run. Oh yeah. And get to the project folder. I'll just go ahead and build this project. If you see here, it's complaining that it's not able to find a Gemfire cache because I have not given it a way to connect to a Gemfire server or like a PCC cluster, right, which is running in the cloud. So how do you test this on your local environment? Like say I want to do unit testing, right? So that's where the Spring Data Test Geode project comes handy, where it mocks out all these objects for us. We don't have to go ahead and write a extensive Mockito framework. Like Spring Data Geode Test project will give us all those capabilities. So if I go and show you the code of how the mocking would work, it is also, again, like annotation based. So what I'm doing here is saying I just want to use, I'll bring down @enable Gemfire mock objects, which will mock all those APIs for me. So let me go ahead and now quickly create, quickly rerun the build, right? So this time, my test case, which was actually failing for where it was looking for Gemfire cache, it should go ahead and pick up the mock object, and it will pass. So if you see, the test cases went through, even though I did not have any server-side connection for this app, right? So this was basically all those mocking capabilities that we have with Spring Data Test Gemfire. Okay. This is the actual app which we already have pushed into one of our environments because it requires we are using MySQL as our backend, and PCC is where the data is getting cached. So since it has some time to load the data and all, we have already loaded the data into the database and pushed the app. So if you see here, this is like what I'm saying is the advantage of using the Lookaside caching pattern is, say, for now, we only have like 100,000 records here. If I say I have like millions of records, like as Netflix was looking into, like say you have 1 billion records in your database, and if you want to query all the data from your microservice from the database itself, every time if you are going back to the database, there is always a latency involved in it. So let me quickly show you how this would work. So first time, whenever I go and query this data, this actually queries like bunch of mock customer information that we have generated through jQuery, and we can do we can query using that customer search service which I had created already. So if you see this, the latency for me, the elapsed time is so. If you see, there are like three things that I'm showing on the screen. One is where this is a cache miss because the data did not get retrieved from the cache. It actually retrieved from the MySQL database, and also the elapsed time, whatever the latency for that request was. So let me go ahead and query the same user again, right? So if you see, there's an order of magnitude faster when the data is getting from the cache. So this looks like a very simple design pattern, but it has a lot of impact in your microservices architecture, and it is very easy to achieve using Spring Data Gemfire. So as and when we start querying the data, you will see that the latency goes on and reduce, right? The reason being, the client is like a smart client that whatever we have with Spring data jumper, it knows how to go and fetch the data from the exact bucket wherever it is getting stored. It does what we call as a one-hop fetch, which reduces the latency for us. That was the demo. Then we had one last conclusion slide, which we wanted to go through.
Yeah, thanks, Nikhil. So, in conclusion, basically, PCC is a highly available cache that your enterprise's application can use, and it's extremely easy to get started with. PCC has a self-service capability. You no longer have to go back to platform operators to give you a cluster. You could just create your own, delete your own, scale your own. It doesn't matter at all. And with the new testing libraries, there'll be an amazing capability that will come to easily mock and test your applications while you're writing without even having to leave your IDE, which is really powerful. That's it. Thank you so much. We can take some questions.
So PCC actually gets installed on Ops Manager, right? Since Ops Manager is can be deployed on multi-cloud. Sorry.
Yeah.
So the question was, is PCC cloud agnostic? So yes, PCC is cloud agnostic. So you'll get the same experience whether you deploy it on AWS, GCP, or on your private cloud, because it is a BOSH style, or it installed through Ops Manager, right? So as soon as it gets installed into Marketplace, you'll use the same CF commands like CF create service for provisioning your PCC clusters. That experience remains the same. Yeah. CF itself is a CLI for PCF. Now, what I meant to say is, if it's so cloud agnostic in our perspective is related to PCF itself. Like PCF itself, we call it as cloud agnostic, right? You can deploy it anywhere. So similar to, that's why PCC also you can deploy it anywhere. That's a question to poke it.
Not yet. It's something that is in our mind, and we're thinking about it. The question was, can PCC be deployed without PCF?
Kind of on a similar question, can you just swap out Gemfire then if you wanted to? Like, Gemfire would have?
In theory, yes. Think of PCC as a Spring Boot is for Spring. So that's how PCC is for Gemfire. You might have to do a lot of configuration to get to the same amount of default security. For example, we didn't show you, but there is a authentication and authorization happening by default when we are connecting to the cluster. That's just there in PCC, and you might have to configure Gemfire to do that in order to use exactly the same code base. Similarly, there are a lot of things like keeping the data always balanced and things like that, which PCC just takes care of, and you don't have to worry about it. Yep. Yeah, the question is, how do we manage the session cache? It's actually really, really easy. It's easier than this. You don't even need an annotation. All you have to do is bind your web application to PCC service instance, and as soon as you push, Java build pack actually recognizes that it's connected to PCC, and it just enables the session cache for you, and it starts pushing the data, creates the region. You don't have to do anything. You'll just start seeing data coming in the PCC cache. How often does PCC refresh the cache? It's actually depending on your region configuration. You can use a proxy region, which never keeps anything on the client side and always goes to PCC cache. or you can have a caching proxy, which basically caches data locally. But if, let's suppose, for some other reason the data gets updated, it invalidates. So there is a server event that gets sent, and it invalidates the cache. And next time when somebody requests, the client is actually going to make a server request and get the latest data. Exactly. Yep. All right. Thank you so
Thank
much.
you so much.